There are two toolboxes still remaining on the Surfaces tool frame that we haven't looked at yet. And the first one is the Modify B-Spline Surfaces, and the second is the Surface Utilities, both of which I've floated here. And I'm going to go through these tools pretty quickly because I want to just show you what their purpose is. We'll start here with the Edit Surface Control Points tool. Now, you've used this one before, where you used it to display or not display the control points of a surface. So I'll skip on to the next one, which is Change Surface Order. And this simply changes the number of U and V lines on a surface to a maximum of 26. Next is this, which is Change Surface Closure. Right now, all our surfaces in this drawing are open, but some surfaces can be closed back to the starting point of the surface. None of the ones here can. For most surfaces, you're likely to see a note saying that the surface cannot be closed. Next is Rebuild a Surface. And all that means is that it's going to sort of refresh a surface with different parameters. Try some of those on some of the surfaces that we've got. Next is Combine Surfaces. And this is quite a useful tool. And it's a little similar to the Stitch Surfaces tool, and it combines two B-spline surfaces which share a common edge. And an ideal candidate for that is this curve and flat surface. So we have to select the first surface, select the next surface, and we data point. And we have a continuous surface. Let's do that again with this one and this one. And now we have a continuous surface. So that is a very useful tool in some circumstances. Now the next one is kind of the opposite. This is Split Surfaces, and we get several options. We can do it by points, by numbers, at creases, in iso curves, and in Beziers. Let's do it by point first. So let's split this entire surface here. So we select the surface, but be careful about this because where you select the surface determines where the point is for the split. I'm going to select it right there. Now, if you notice, as I drag my cursor, you can see the secondary surface altering its size. So I'm just going to data point about there. And what I get are two separate surfaces. So again, depending on where I first select and where then I drag the cursor depends on how the surface is split. So experiment with that. It is a very useful little tool. Next up is the Surface Handlebar tool. This will modify the shape of a surface by dragging its handles. This tool is a little more versatile than dragging the surface poles with the Modify Element tool that you looked at previously. So we select the surface and select a base point for the handlebar. Let's just pick this point here. Let's data point there. Now we see the handlebars turn up, which are just a series of selectable boxes. So if I click on this and drag, I can drag and change the surface quite easily. Let's do a quick rotate to see what we've got exactly. Yeah, it's changed that surface quite considerably. Okay, let's undo it. And the last tool here is Twist Surface. Now this is a little trickier to use, and I've added just a plain block here. And I've drawn a line on the block to use as the axis for the twist. Now apply a fixed angle. Well, let's make that 90 degrees. Infinite's off. And you have to watch the prompts very carefully, and it is a little obscure. First we select the B-spline surface. That's this one. Then we click on the start of the twist axis. Well, this is my axis here, so I'm going to snap to that point. Then it wants the end of the twist axis, or that will be that point. Then it wants me to either modify the axis, which I don't want to do, or input the first reference point. Well, I'm going to make this the first reference point. Then it wants the end reference point. I'm just going to select over there. And there's my surface. Let's have a look at that. So that has twisted the surface quite nicely. Notice the back end is twisted. This end has remained horizontal. So that works very well. So I suggest you play with that quite a bit. All right, moving on. Let's move up to the Surface Utilities toolbox. First tool is Convert to a Surface. And I've added a solid primitive slab. And I'm going to convert that to a surface. So remember, this is a solid slab. We're going to convert the surface into a smart surface. We won't keep the original. Data point, and if you notice, we now have a box-shaped surface. This is hollow. Let's just prove that to you. It is hollow, and it's just a surface. Kind of neat in some circumstances. Next is the extract points from surface or face. Now, what this is doing is adding control point locations to a surface. We can set the number of U and V locations. Now, it's 4 and 4 at the moment, so we'll see what this does. So what I'm going to do, first of all, I'm going to undo those last two operations, and I'm going to have a look at this flat surface first. I'm using a point array at the moment, but you could use other differences. Point array. I'm going to select the surface, and we see some symbols showing up, and we'll data point to accept. And what we get are a series of 4 short normals, because we had normals set in the toolbox. So these are 4 normals in this direction and 4 normals in this direction for a 4x4 grid. If we change this to different UV point numbers, we'd have a different set of points. But what you have now are points on this surface. So that is the point on a surface. And you could now take these reference normals and apply them somewhere else to create another surface. Same basic idea. So try that tool on some other surfaces that we already have. Next is extract isocurves. Now you've already used this one when you were developing this surface. Next one is planar slice. This tool generates a planar section through elements. You can use a cutting plane, this one, or you can use a slice which is defined by 3 points, or you can use the view itself to provide the cutting plane. Now, the generated planar section remains in place in the elements and can be moved to another location for further operations. In addition, if you prefer, the planar section can be automatically sent to a separate output design file. So you would set up a design file here and browse for that file. We can assemble the segments of the planar sections so that the cut sections can remain together. You can draw, say, a block element and locate that in the elements you want to slice and use that as a cutting plane. Try it and see. Try using an output file, etc., etc. Next is compute intersections. You're going to use this tool in an exercise coming up very shortly, but I'll show you how it works. And this is the use of this particular element collection. What I've got here is a surface in a rectangular formation with a single line running through the surface. And what this tool is going to do is to find the intersection points between these two elements. It will place normals at the computed intersections, and we can use those normals for further operations. So let's just try this tool. Select the elements for the first group and the element for the second, that's this one, and data point. And we see the surface normals. That is a surface normal, that is a surface normal. If I shade it, and let's do a rotate, you'll see exactly what I mean. So where the line penetrates the surface, we now have generated a normal, which is, of course, normal to the surface of the first rectangular tool. Now we can use those intersection points for other operations. Now, moving on, the next one is unroll developable surface. So what I'm going to do here is use this surface, and we're going to unroll it into a flat surface. Follow the prompts, select a surface, define a point at which to unroll. Well, I'm going to choose that bottom corner there. Then we want a second point, so I'm going to define a second point up there. And there's my surface. Let's shade it. And let's do a rotate. We see that we have a flat surface, which represents this surface unrolled into that shape. Now, this is not necessarily very accurate. And the accuracy is actually controlled by the number of U and V points. And I've got these at 64. The higher the value, the better the unrolling. Try some of those with different surfaces that you already have. Just take it with a pinch of salt as far as being absolutely accurate as an unrolled shape. Next tool is Surface by Image. And essentially what this does is take an image file and develops a surface from that. If you have some image files floating around, try it and see. It's not particularly spectacular, but try it anyway. Next up is Show Surface Curvature. Let's zip over here and try that on this one. Now you're seeing a graphic display of the surface curvature in terms of color values. So the last tool is the Match Surface Settings tool, and it does exactly what you think it does. It will match the current settings of this surface and make that the current settings for all surfaces that you generate. So simply data point on a surface, and that's all that happens. The tool goes back to the element selection tool, but the surface settings have been set in the background. Please practice some of them, give them a try, and then in the next video you can move on to an exercise, which I really want you to do.